In this lesson, we will learn how to quickly multiply and divide numbers by powers of 10. We will begin with multiplying. Now, when we multiply a number by a power of 10, the rule is to move the decimal place one space to the right for every zero in the power of 10 we are multiplying by. To demonstrate this, let's begin with this example. Here we want to multiply 23 by 100. Since there are two zeros in this power of 10, we must move the decimal two spaces to the right. Now in 23, the decimal is assumed to be here. So in order to move the decimal two spaces to the right, we must first add some zeros after the decimal like so. At this point, we can move two spaces to the right, 1, 2, and place our decimal here. So 23 times 100 is equal to 2300. Alright, let's try another one. We want to multiply this number by 1000. Since 1000 has three zeros, we must move the decimal three spaces to the right. When we do this, we get the following product. In this next example, we are multiplying a number by 100,000. Since 100,000 has five zeros, we must take our number and move the decimal five spaces to the right. So first, we must add some zeros. Now, when we move the decimal five spaces to the right, we get the following product. Okay, one more example. Here we must recognize that 10 to the power of 4 will have four zeros, just as 10 to the power of 5 will have five zeros, 10 to the power of 6 will have six zeros, and so on. Now, if we want to move the decimal four spaces to the right, we must first add some extra zeros. Now, when we move the decimal four spaces to the right, we see that 3.74 times 10 to the power of 4 is equal to 37,400. Okay, now let's see what happens when we divide numbers by powers of 10. The rule here is almost identical to the previous rule, except when we divide a number by a power of 10, the rule is to move the decimal one space to the left for every zero in the power of 10. So to divide this number by 1000, we must move the decimal three spaces to the left since 1000 has three zeros in it. When we move the decimal three spaces to the left, we get the following quotient. Let's try another one. Since we are dividing by 10,000, and since 10,000 has four zeros, we must take this number and move the decimal four spaces to the left. To do this, we must first add some extra zeros in front of the number. Now, when we move the decimal four spaces to the left, we get the following quotient. Okay, one last question. Since 10 to the power of 6 has six zeros, we must take our number and move the decimal six spaces to the left. So, first we must add some extra zeros in front of our number. At this point, when we move the decimal six spaces to the left, we get the following quotient. Okay, let's summarize. In this lesson, we learned how to quickly multiply and divide numbers by powers of 10. In this lesson, we will take an introductory look at fractions. Now, as you can see from the fractions shown on the number line, some fractions are positive and some are negative. When it comes to negative fractions, it's important to note that there are different ways to denote the same fraction. For example, the fraction negative 2/3 is equal in value to the fraction negative 2 over 3 and the fraction 2 over negative 3. Alright, now let's take a closer look at fractions. In the fraction 3/4, the number on the top is called the numerator and the number on the bottom is called the denominator. Now, one way to look at fractions is to think of them as parts of a whole. For example, if we take this circle and divide it into four equal pieces, then each piece represents 1/4 of the entire circle. So three of these pieces together represents the fraction 3/4 or 3/4. Another way to look at fractions is to think of them as division. For example, the fraction 6 over 2 can be thought of as 6 divided by 2, which equals 3. Notice that if we apply the concept of a fraction as part of a whole here, we can think of 6 over 2 as 6 halves. Notice, however, that if we take three of these halves and match them with the other three halves, we end up with 3 wholes, or 3. So as you can see, the concept of a fraction as part of a whole can be very similar to the concept of a fraction as division. Now, when working with fractions, it's important to know how to recognize and create equivalent fractions. Two fractions are considered equivalent if they represent the same value. So, for example, 1/2 and 5/10 are considered equivalent fractions, as are 7/9 and 14/18, as well as 3/5 and 30/50. The process of creating equivalent fractions is very straightforward. All we need to do is multiply or divide the numerator and denominator by the same number. So, for example, if we take the fraction 2/3 and multiply top and bottom by 5, we get 10/15. So 2/3 and 10/15 both represent the same value. Similarly, if we take the fraction 10/11 and multiply top and bottom by 7, we get the equivalent fraction 70/77. We can also use division to create equivalent fractions. So if we take 24/36 and divide the numerator and denominator by 4, we get the equivalent fraction 6/9. Similarly, if we take the fraction 35/45 and divide top and bottom by 5, we get the equivalent fraction 7/9. Now, when talking about equivalent fractions, we need to know about lowest terms. Notice that if we take the fraction 2/3 and multiply top and bottom by 5, we get 10/15, which is equivalent to 2/3. Similarly, if we take 2/3 and multiply top and bottom by 11, we get another fraction that is equivalent to 2/3. In fact, we can create an infinite number of fractions that are equivalent to 2/3. Now, of all these equivalent fractions, we say that 2/3 is written in lowest terms, since 2/3 is the fraction that has the smallest integer values in its numerator and denominator. Another way to say this is, a fraction is written in lowest terms when no integer greater than 1 will divide into both the numerator and denominator. As you can see, there is no integer greater than 1 that will divide into 2 and 3. Okay, now let's take this definition of lowest terms and use it to rewrite fractions in lowest terms. So, for example, let's say we're working on a question and we calculate the answer to be 28/35. Since 28/35 is not written in simplest terms, we would not find this fraction as one of the answer choices. So we need to simplify it. Our goal then is to find a fraction that is equivalent to 28/35 that uses the smallest integer values in its numerator and denominator. Now, to create equivalent fractions, we multiply or divide the top and bottom by the same number. Since we want to simplify this fraction, we will divide top and bottom by the same number. So if we divide top and bottom by 7, we get the equivalent fraction 4/5. And since there is no integer greater than 1 that will divide into 4 and 5, we say that the fraction 4/5 is written in lowest terms. What about the fraction 48/64? Well, if we take this fraction and divide top and bottom by 8, we get the equivalent fraction 6/8. Now, is 6/8 written in lowest terms? Are there any integers greater than 1 that will divide into 6 and 8? Well, sure, 2 divides into 6 and 8, which means 6/8 is not written in lowest terms. We need to simplify it further. So if we divide top and bottom here by 2, we get 3/4, and 3/4 is indeed written in lowest terms. Okay, another topic related to fractions is that of entire fractions and mixed numbers. In cases where we have a fraction where the numerator is greater than the denominator, we can express this fraction in two ways. We can leave it as one fraction, or we can write it as a combination of an integer and a fraction. Now, if we leave it as one fraction, it is called an entire fraction, also known as an improper fraction or simply a fraction. If we write it as a combination of an integer and a fraction, it is called a mixed number. This is also known as a mixed numeral or a mixed fraction, to name a few. Now, don't worry about the names of these. What's important is that you know how to convert one form to the other form. So let's begin with converting entire fractions to mixed numbers. To do this, first we determine how many times the denominator divides into the numerator. Now once we divide, the remainder becomes the numerator of the new fraction, and the denominator remains the same. So, for example, to rewrite 23 over 5 as a mixed number, we first recognize that 5 divides into 23 4 times, so 4 will be the whole number of the mixed number. Now when we divide 5 into 23, the remainder is 3, so 3 will be the numerator of the mixed number, and the denominator will be the same as in the entire fraction. Similarly, to convert 71 over 10, we first recognize that 10 divides into 71 7 times with a remainder of 1. So 7 will be the whole number part, and the remainder of 1 will be the numerator, and the denominator will be 10 as in the entire fraction. Okay, now let's convert mixed numbers to entire fractions. The process is as follows. First, we multiply the whole number by the denominator, and then add this product to the numerator. The result becomes the new numerator, and the denominator stays the same. For example, to convert 6 1/3 to an entire fraction, we first multiply 6 and 3 to get 18, and then we add the numerator of 1 to get 19. So this becomes our numerator. We then keep the denominator the same as in the mixed number. So 6 1/3 is equal to 19/3. Let's try one more. To convert 11 2/7 to an entire fraction, we first multiply 11 and 7 to get 77, and then we add the numerator of 2 to get 79. So this becomes our numerator. We then keep the same denominator as in the mixed number. Okay, let's summarize. In this lesson, we learned how to create equivalent fractions. We learned how to write fractions in lowest terms, and we learned how to convert entire fractions into mixed numbers and vice versa.